Good afternoon, and good to see some of you back again. For those that haven't joined us before, my name is Mark Stewart. I'm a director of the RSK Geosciences business, and I'd like to welcome you all to the next of our Down to Earth webinars. Today, this has been given by Mark Perry from Leap Environmental on nutrient neutrality. First of all, I'm going to quickly go through some housekeeping with you. So, just to remind you, all your microphones are automatically muted, so we can't hear you. Hopefully you can hear us. During the presentation, you can post questions and we'll have a Q&A at the end of the presentation. We'll answer as many questions as possible, but if any can't be answered, then we'll have your emails and we'll get back to you afterwards. Shortly after the webinar, we'll provide you with a link for a short survey. So if you could take a few minutes to provide any feedback so we can improve future webinars, that would be appreciated. So Mark is a principal geoenvironmental engineer with Leap Environmental. Leap are our RSK group company that we've worked very closely with. Mark has over 20 years experience within site investigation and land contamination sectors and has formerly been a regulator at the Environment Agency. He's just celebrated 6 years at Leap Environmental and has been involved in a number of water quality studies for developments within the areas requiring nutrient neutrality assessment. It's quite hard to say. So without further ado, over to you, Mark.
Good afternoon, everyone. So the presentation is to cover nutrient neutrality, looking at large-scale developments and water quality studies that we've undertaken to support some of the assessment work, environmental permit applications within them. So we're going to cover nutrient neutrality. What is it? How does it come about? A little overview of water monitoring, type of practice that you might undertake, examples of how that works, and ending with a brief case study where we've used the water quality data to sort of support nutrient neutrality, but also an environmental permit application. So what is nutrient neutrality? Well, it can be described as a means of ensuring that new development does not add to existing nutrient burdens. So linked to a 2019 European Court of Justice ruling, so-called the Dutch case, which prevents by law the additional nutrient loading to designated sites that are considered to be within an unfavourable condition, so at risk of having detrimental impact to them, essentially. The designated sites can include special areas of conservation, Ramsar sites, triple SIs, special protection areas, or a combination of the above. And in England and Wales, they're protected under the Water Framework Directive Regulations 2017 and the Conservation of Habitats and Species Regulations 2017. How they're formed looks at the nitrogen nutrient loadings to the environment, which support these protected sites, designated sites, can be formed largely by agricultural sources, and that's what's shown in the top bar, current status, but also wastewater treatment work inputs. And there's this mythical other, which we could consider things like road runoff or discharges from process industry, for example. And you can see that they total up to exceed this environmental capacity, which we could take as being environmental capacity of a designated site, above which there would be detrimental harm. So the idea is to sort of reduce the overall nutrient loading or pollutant loading to the environment, into the catchments that support these designated sites, with an overall objective over time with implementations of different mitigation measures to create a bit of headroom, a bit of a buffer, so that we can allow for new development to occur. So that's what's shown in the bottom graph there, additional space below the environmental capacity so that protected sites remain as they are. So what does it mean for developments? Well, any new developments must demonstrate that there is no net increase in nutrient inputs into the catchment. So that's achieving nutrient neutrality. And it's just safe to say that it's in catchments that feed into the designated sites, not all developments. And that can be achieved through, well, mainly through effective on-site treatment. So that might be a design and construction of a new wastewater treatment works for that particular development, inclusion of suds, so maybe detention basins to treat water, and water efficiencies, and probably likely to be a large combination of the above. We could also look at offsetting or trading with other sites within the catchment. And within the solvents nutrients catchment, there is trading of nutrients, a bit like carbon trade. Also, you can do this with a specific site. So we're working with a local authority who are developing a brownfield site. It's quite a small footprint. The red line boundary doesn't allow for the inclusion of any of these on-site treatments. Wastewater treatment works for a SUDS system. And they're using another site within the local authority control, their ownership, which they can create a managed wetland, which will enable them to offset that nutrient loading from the development site. But it's also possible, although probably uncommon, to demonstrate that there isn't an impact. We were involved in some consultancy support looking at a single dwelling with a package treatment plant discharging to ground. It was 80 metres to groundwater in chalk, and it was questionable to see which way the effluent would actually discharge, which way would it ultimately flow. Would it flow based on the groundwater divide that it was located in? Would it flow out of the catchment for the protected site, or would it flow towards the designated site? And the work that we were involved in was looking at which way the groundwater may flow based on their study information, but also just considering that the unsaturated zone, the amount of attenuation and the time it would take for a discharge to go through the unsaturated zone, reach the groundwater, and ultimately flow slowly towards the surface water, and then discharge towards the catchment and then into the designated site. The starting point for all of these is always going to be an establishment of the current conditions, proper understanding, and that's used to support nutrient neutrality assessment and also environmental permit applications to the Environment Agency. And the environmental permit application is going to be needed for those wastewater treatment works, so actually fundamentally linked to achieving nutrient neutrality. So what's involved in nutrient neutrality assessments? Well, part of it is this calculator. This is actually from the nitrogen budget calculator for the solvent. Essentially takes you through a series of stages of considering all the inputs, the existing site, what's proposed, the different land uses, and then works out how much nutrient reduction you will achieve against the existing standards, existing levels. So it's another screenshot from the same calculator. So stage one, it looks at the number of properties within the development. So just a simple number there. Net population per housing unit. So it's taken Office of National Statistics numbers, which is 2.4 people per house, but you might want to change that number depending on what your actual site requirements are. For instance, you could argue that, say, a retirement village or sheltered accommodation would have a different number compared to that value. You also take in things about how much water usage there is. So we're assuming there's 110 litres per day per person. That might be correct, but obviously the more water you're using, the more water you've got to treat. And then there's parameters around about the design configuration of the actual wastewater treatment works and the performance of it. Stage two there just shows you the different land uses and the area that they cover. And this is taken from the Stour, which is another catchment, which shows the nitrates and phosphorus loadings dependent on the different types of land use, agricultural land use. And you can see very quickly that, say, for a poultry or a pig or a dairy farm, the nitrate loadings are much higher than, say, for lowland grazing or horticulture, which is a really important consideration when you think about having to compare the existing conditions against your proposed development. So that almost the higher the loading to begin with, the more chance you have of achieving nutrient neutrality through your design. And the scale of these catchments, they're pretty big. This is from the solent nutrient catchment. This is showing surface water catchments. They cover large areas. Essentially, the water that flows from the land discharges to the solent, which is the water between the Isle of Wight in the south there and the mainland. It also incorporates some of the harbours, Manxton Harbour or Chichester Harbour. And you can see that it takes in a good chunk of West Sussex, vast majority of the Isle of Wight, good proportion of Hampshire and some of the surrounding counties. So we're looking at very large scales, and that includes a large number of developments as well. It's another catchment. This is for the Stour. This is related to the Stogmarsh, which is the site we'll look at in a little bit more detail in a bit. It's the brown, orangey brown colour in the top right there. And again, you can see that the various catchments that make up the overall catchment to the protected site. So what do we do? Well, we're collecting water monitoring. What do we use it for? We want to establish the conditions of the water environment. And every time we go out and take a water sample, take some information from the environment, we're establishing the current conditions, the current state of water quality. We use all the data from all the various visits to then identify a trend or a range, determine baseline conditions. We'll use data, say, for water quality, levels of nutrients or contaminants. We'll look at general water quality, really good indicators to see what's actually changing, how things are evolving over time. We'll look at maybe flow rates within rivers, how much water is flowing through. Within boreholes, we're looking at groundwater levels, how they vary seasonally, and ultimately determine groundwater flow direction. Really important field observations, kind of the unsung hero of the piece, because that can actually be really important in understanding and interpreting your lab results. We had an instance in one of our water studies where we had really well-established range of results. We knew roughly what was going on with the levels of nutrients, but then we had a sudden spike, quite an elevated spike across a number of parameters, some of them 2 orders of magnitude and greater. Clearly showed something had happened. We went back to the monitoring team, checked with them with their field notes, looked at the photos they'd taken from the visit, and it showed that actually around that time with the visit, there had been some vegetation clearance and possibly some desilting of the watercourse. Obviously, stirring up of the sediment that's rich in nutrients at the bottom of the watercourse had led probably likely, to that sudden spike in nutrient levels. And subsequent monitoring visits actually showed that the levels then started to reduce, which we'd expect from that type of activity. So when we undertake surface water monitoring, we're going to have to consider quite a number of things. First, we're going to have to find some suitable locations to take our samples from. We want to look at the spacing and the distribution of those monitoring points. We're going to have to take into consideration whether there's a discharge from an effluent works or something, or a tributary. Do we want to include the sample point above, upstream, or downstream of that point? And how does that fit in with our overall spacing of monitoring points? We'll look at maybe tidal condition. How does it vary? And some physical constraints, maybe structures. Are they going to change what water information we're going to collect? Is it going to make the sample representative or not? And we can see within the image here for poor old Smallville, we've got 5 monitoring points. Discharge point is indicated to say be 0.3. So we've got monitoring points upstream and downstream, so we can see how water quality changes over that stretch of the watercourse. When we identify a suitable monitoring point, we've got to consider the health and safety of the people who are doing monitoring. So we're looking at depth of water, we're looking at some of the physicality, the physical access into the watercourse or not. And simply, if it's too deep or not appropriate, we'll be looking for, say, somewhere like a bridge or a suitable point from the site to take a sample. The equipment is fairly basic. We're looking at maybe a sampling can or a bucket, a pole, some sort of flow meter and measuring devices. We can get sort of volumes of water that are flowing through. I would be taking infield water quality results, physiochemical values, using a probe like a YSI or an Aquatrol. For groundwater monitoring, it's a little bit more tricky, a little bit more involved. We're very much reliant on the monitoring boreholes that are installed. So they've got to be constructed appropriately. That means maybe the responser in the slotted section has got to be allowing us to sample the water body that we're interested in, so whether that's the deeper water or maybe the shallower water. They've got to be to the correct depth. Can't really take a water sample where the borehole isn't deep enough to reach groundwater, but that in itself does tell you something, because it's giving you an indication of the unsaturated settings, at least an idea anyway. And we also want to consider the position of them. We want to know which way groundwater is flowing, so we want to take groundwater samples that are upgrading and also downgrading. We're going to consider purging and sampling methodologies, because we want representative samples. And the equipment we're going to use some sort of low flow pump, perhaps a peristaltic or a bladder pump, depending on the depth. Or we may use a baler or sort of Waterera foot valve system. We're going to record the groundwater level using a dip meter, and again, we're going to use one of these water quality probes just to get those in-field data that we can't get from the lab, like temperature. And slightly aside, but included on this slide is level loggers. So groundwater level loggers, they've been around for quite a while. I think they're becoming more prevalent, I think. But they're really good bits of kit just to deploy to a borehole to record groundwater level variation over a number of weeks or months, just to get that change in water that you don't get necessarily quite in resolution that you do with just manual dipping. And aside from the level logger that I just mentioned, the surface water and groundwater monitoring that we would typically do is what's termed as spot monitoring. So it's only really representative of the moment in time that you take that sample. It doesn't really tell you much outside of that frame. But you could look at continuous monitoring. By that, more sort of telemetry or automated systems that give you a higher frequency of samples or monitoring, measurement or monitoring parameters. That leads to a larger data set. So even if you're collecting groundwater level at, say, 15-minute intervals, suddenly you've got an infinitely bigger data set than just your manual dips once a week, once a fortnight. And you can do the same with, depending on the needs of the project and the specifics, but you can do that for also water quality parameters and things like nitrates as well. You're not, you will obviously end up with a larger data set because you're collecting more information. And because you're not constrained by some of the practicalities of actually having to go back and repeat that monitoring through the day, you're going to get some savings as well, because you're not going to have to send as many people out as often. So there's a time and a fuel saving, and those people can then go and do other projects for you. Because you've got a larger data set, you can validate much more reasonably your conceptualization. So you'll understand how the water is changing, the water quality, the water level is changing over time, and that will help support a robust risk assessment. There are challenges though. The results, they're not necessarily going to be accredited. You're certainly not going to get pathogens from it, where they have to be grown and cultured in a lab under certain conditions. And there's going to be some issues around securing them, the monitors. You're going to want to deploy them in locations that you can fix them down to, say, a bridge or some sort of other structure. There's also issues around cost. They're not as cheap up front as sending a person out to go and collect a water sample. Therefore, where you're going to deploy them, you're probably going to deploy fewer of these units. You're probably going to have less of these continuous monitors. And that will have an impact on how far you can take that information. But actually, if you use them smartly, you can use, I've used it on a project where we had 18 monitoring points. So surface water was taken on a weekly frequency from 18 locations. But what we didn't know was outside of that time frame what was happening, because it was we're looking at misconnections study within an urban environment. And what we used was a couple of water quality probes with a telemetry system, and it helped us pick out which of the tributaries the bulk of the contamination is coming from, and informed where we went with our, refined our monitoring visits thereafter. And also confirmed and validated, well, actually, yes, there is a bit of a spike in the morning and again at lunchtime and again in the evenings. So sometimes we're omitting that from our monitoring. We also have to consider things like power requirements. It's not going to be very often you're going to use mains connection. Solar is possible, some sort of battery system depending on the draw as well, how much power is needed and how frequently you're taking the samples. But hydrogen cells are becoming a bit of an interesting area of development, somewhere between sort of a solar connection and a battery in terms of how frequently they need topping up. And you're still going to need manual visits. You're still going to have to visually go and take a check to see that they're okay and maybe do some maintenance, but also do some additional sampling. But at least you can roll that in with, say, your spot monitoring. So this is us, lots of people donning waders, getting into watercourses. And where have we been doing it? Well, predominantly the Stock Marsh. It's located just outside of Kent, just outside of Canterbury, northeast end of Kent. It covers an area of over 600 hectares. Includes inland and coastal and marine wetlands, lakes and lagoons, which supports a number of uncommon wetland invertebrates and plants. It's partly ground surface water fed from the adjacent Great Stour, which is the river that flows through the centre of Canterbury, if you've ever been there. And it's being impacted by elevated levels of nitrogen and phosphate. And it's thought that the source of these are from wastewater treatment works within the catchment. They're currently going through an investigation or assessment process, which is due to report shortly. From there, that will identify what works are going to be needed, where they're going to be placed and how long it's going to take. Obviously, capital funding is going to have to be secured and then implemented. So realistically, no improvements to the wastewater treatment works are expected between 2030. So that means that developments that are online now or proposed, there's 8 years before there's any real sort of change in the environment, any sort of improvement. And that's quite a way, that's quite an issue, which means a lot of developers are going to have to implement these on-site mitigations. So what we found during our studies, well, we've gone out to locations that should have had water. The image on the left-hand side there clearly shows on the maps that there is water there. Wasn't when we went to survey it and locate the position. There was subsequently, after 3 or 4 rounds, we were able to monitor water. So clearly there's an element of groundwater flow here. The image is on the right-hand side, so from the right. When we went to Recce and identified the monitoring points, definitely water there, not a single drop for the entirety of the monitoring period. So that's again a groundwater issue. Instances of too much water. Clearly, we're not going to get in either of those with waders on, but what we were able to do was take samples from the bridge and use nearby EA gauging data to supplement what we would normally do in the watercourse. But most of the time, it was just right, just the right amount of water. We've also found, and this is the sort of beginning of the case study, is the evidence of pollution. The image on the left-hand side shows the sampler point for a development site. This is where the effluent from a wastewater treatment works would discharge. This is essentially where new effluent water, treated effluent, would be discharging into. What you can see just about in there is evidence of sewage fungus coating some of the rocks and the bricks in the bottom of the watercourse. What you can't smell is the odour. What you can't see is the mosquitoes, which is why my colleague there is covered from head to toe in her PPE, peeking out. It's not because it's cold, it's about 20 odd degrees and she's just being buzzed by mosquitoes. In her hand there is actually the Aquatrol, which is what we're using to record the in-field water quality parameters. So from that baseline monitoring, we actually confirmed the visual evidence and the factory evidence of contamination. Results showed that there was very elevated levels of pathogens and other nutrients. And it led us to then undertake some further investigation works, starting with desk-based work to identify possible sources, and then ultimately walking up through the watercourse, taking additional samples together with the field probe, just to get an idea of what things were changing. And ultimately we found this discharging pipe. It's 8 inches in diameter, it's a concrete pipe, and it actually leads from our client's land. So just taking back to a second, nutrient neutrality to establish what the existing conditions are compared against the proposed. Well, clearly, this is from the existing land use. From here, a drainage survey was undertaken, which identified that it related to a misconnection for the seasonal workers that which worked on the farm, which our client had purchased. It was a series of caravans, between 80 and 100 people on there at any one time, living in caravans with washing facilities and kitchens. That effluent then, foul water, then discharges into some sort of septic tank with the pumped overflow discharging into the surface water pipe, which is what we see discharging here. So it also found some other misconnections, which are all not great. It's all the pollution. The misconnections were stopped, no more pumps discharge. So actually there's a big improvement to the situation already. Follow-up monitoring showed that the water quality was improving, which is a really good thing, and actually that'll all be decommissioned as part of the redevelopment of the site. So again, back to that existing versus proposed development. So this is actually the same site, but just to satisfy the other aspect of it. So the client has got to construct a wastewater treatment works. You can see down at the bottom of the image there. And that's to provide treatment of the foul water from the development. So I think it's a couple of hundred homes there, actually, this one. Not the biggest of developments, but it's still pretty dense. The wastewater treatment works will cope with the loadings and achieve the requirements of the environmental permit. But that discharge won't still be good enough to achieve nutrient neutrality, which is an interesting conundrum, since you've achieved environmental permit requirements, but not sufficient reduction for nutrient neutrality. So in this instance, they've used the already designed sludge basins that are already included in the development plan to then enhance the treatment of the effluent through discharging the water through the series of basins before then discharging out through the bottom of the site, off-site into that watercourse. And as part of that, they're using these floating islands. They're a really good little system of specially planted islands. They're floating with the rootlets dangling into the watercourse, which provides additional treatment, removal of nutrients. The image on the right there is actually from a project I was involved in at the Environment Agency, which was dealing with urban runoff, misconnections, and how that influenced the potential failure against the revised bathing water project, bathing water directive that had come in. So just to sort of finish up, the nutrient neutrality is there to protect designated sites. Improvements may include on-site, but also off-site balancing. Overall, it's a part of the solution is to look at maybe treatment, but it's ultimately it's going to be a reduction across a range of potential sources. In understanding nutrient neutrality, you have to determine the current and the anticipated nutrient inputs. Ultimately, it does really require an understanding of what is going on in the actual environment, not just on paper. And part of that, you use surface water monitoring surveys. Ultimately, though, you may still need to undertake some additional treatment processes, which is an example at the end. And the big take home for any developers is that if you're going to do a development within a catchment of a protected site, a designated site, you really should consider nutrient neutrality at a very early stage in the design works, because it's very difficult to incorporate all the mitigation measures into your existing design footprint. That's everything from me.
Thank you, Mark. That was great. Okay, we've got a few questions, a couple of questions that have come in, so there's still time. If anyone wants to ask a question to Mark, please put it in the text box and send it over. So firstly, what changes or improvement in monitoring methods would you like to see?
I would like
your
to
camera
see...
on, Mark, or so we can see.
Sorry? No camera on. I'd like to see a move to more automated systems. I think they're fantastic. We use them for things like gas monitoring, and they give that extra dimension, that extra refinement to our assessments. They're really, really powerful. Not used speculatively, I think that's the thing, and it's got to be directed towards the particular requirements of the project. So investigating a problem using the remote monitoring or the remote sensing approach, and just building that data set, and then how you use the data is the key bit.
Okay. How do you think the anticipated improvements from nutrient neutrality will be or can be validated?
That's going to be a big difference, because a big challenge, because the environmental permit requires ongoing monitoring. So there's going to be ongoing monitoring from Environment Agency from the discharge from the wastewater treatment works under the permit requirements. But the nutrient neutrality has got to be agreed up front. So as far as I see, I've not seen any ongoing monitoring requirements that actually demonstrate the level of improvement. So I think actually that's going to be the big challenge, is to get some case studies going. That will also help support new developments, new uses of SUDS and other techniques and technologies. Yes, basically improving the number, the data set that people can draw upon, almost like a library. Okay,
questions are flooding in now, you'll be glad to know. How long will monitoring go on after the site is constructed or built?
So for the wastewater treatment works, that's as long as the permit's in place. And for, again, back to the nutrient neutrality, it stops essentially. There'll be obviously some monitoring that Natural England and others will be doing to see what's actually happening at the designated site. But beyond that, I'm not aware of any additional monitoring will go on. So that's an interesting conundrum. Something I'd like to see is more monitoring, just to demonstrate that they're effective.
Okay. There's a comment from one of our clients that says, are we aware that Natural England are currently upgrading all NN guidance to a single form due to be published in March, April, based on the Hereford model?
There's been several iterations, but we've got to work with the current information we have. So sites that we're involved in at the moment have had to submit on the current guidance. So yes, there's always going to be a new guidance update, but you're always constrained by what's available at the time of submission. So one to watch out for, I guess.
Yes. Okay, you mentioned 4 different groundwater sampling methods from boreholes. Is there a preferred method? Given the differences, is it possible to compare results obtained from different methods?
The different methods, it really depends on the borehole and the requirements. And I think in terms of a strategy, there's never a right or a wrong way, but it's the best way, and it's specific to that borehole. So at the outset, you would need to determine what you wanted to achieve, and then see the performance of the borehole. I used to do, as part of my regulatory work, looking at boreholes and surface water and groundwater monitoring as part of landfill works. And within one site, there were 3 different approaches to water monitoring, ranging from just a simple purge from an artesian well through to various stages of purging volumes. So I think it really does come back down to the individual borehole. The physiochemical parameters are the bit that you really want to watch to see that actually the water has stabilised and that the water you're sampling is actually representative of the groundwater. But again, depending on what the specifics for the project is, depends on how you approach that.
Okay. And in discussions with water companies, are there precedents in using some of the headroom in discharge consents as part of the solution?
As far as I'm aware, no. I'm not part of those discussions, but certainly from the work that we've seen, Natural England's consultants are looking at the information that's provided, not the additional things that may be going on inside. Personally, I think it should be a more open discussion, and I think it's kind of an interesting position to be in to deal with both the Environment Agency, also Natural England, and then you've got the water companies, and there's other stakeholders involved too. So I don't know the answer to that, I'm afraid.
Okay. Do developers try to bring down other sources like misconnections, agricultural inputs, highway runoff to give their site some headroom?
It's a time of change because actually developers are now, depending on the developer, there's obviously some are a bit more aware of the situation, and ultimately the stumbling block of no, you can't have your development until you do X, Y, and Z does seem to focus the mind. A lot of them are focused a bit more, from my experience anyway, on dealing with the problem at hand. But as time goes on, as I said, particularly for the Stog Marsh issue, that's another 8 years of this. So as developments come forwards, I think that there will be more of a look out to see how they can solve the problem more holistically rather than just within their sites. Certainly with the trading, nutrient trading within Solent, that's looking at changing agricultural uses from, say, an intensive one to more of a woodland or a wetland setting. So I think the opportunities are there, it's just identifying them. Though it will be driven by problems that pop up.
So who, I'm not sure I'll read this out correctly, who would make the EA discharge permit? We are being told only water companies can do this in sewered areas. Is this true?
I'm not sure I understood the question.
No, there might be some typos. I think we had a few questions from the same person, and I won't go through them here, but we will be in touch with you, Mark, to get back to you on those points. Would this session be recorded? Yes, this session is being recorded, and you'll find it soon where all the others are on YouTube. So we'll draw it to a conclusion there. Thank you very much, Mark. That was really good. Can I remind you all to fill in the feedback survey once you receive it? Our next topic hopefully will be on building foundations for net zero and a carbon calculator. So thank you and enjoy the rest of your day.